AP problem number 2, chemistry, AP chemistry. Hi, I'm Logan. Oh, I forgot to write down the actual problem. Let me bring it up here. Okay. A 0.1, oopsie. There it is. A 0.150 G sample of solid. I don't know if you can see it, but I hope you can. A 0.150 G sample of solid lead 2 nitrate is added to 125 milliliters, 125 milliliters of a 0.1 molarity sodium iodide solution. Assume no change in volume of the solution. The chemical reaction that takes place is represented by the following equation, which I've written down a few times in the thing here. Like right here, it's PbNO3 2 times 2 NaI goes to PbI2 2 NaNO3. This is balanced already. There's 1 Pb, 1 Pb, 2 NO3, 2 NO3, 2 Na, 2 Na, 2I, and 2I. So the first question, or the first part A, list an appropriate observation that provides evidence of a chemical reaction between the two compounds. For this one I just said we know a chemical reaction occurs because a solid is formed in the form of a precipitate, which will end up being PbI2. For B, we were supposed to calculate the number of moles of each reactant. So I took the grams of PbNO3 and divided by the molar mass to get the moles, which is 0.000453 moles, or 4.53 times 10 to the negative 4th moles. And then here I took the liters of NaI times the molarity of the solution to get 0.0125 mole. We move down here. For C, we're supposed to calculate the limiting reactant, show the calculations that support the identification. So I took these numbers, 0.000453 and 0.0125, from the first slide here and here, just to be able to visually see them on the presentation. So for this one, we know there's 2 NaI for every 1 PbNO3, as shown in the equation right here. So we take, I took the molar mass of this, or the moles of this times 1/1 to get those moles, and then took the moles of this times 1/2, because we want them to be, we want the same amount, and it's 0.00625. We could also do it the other way. We multiply this one by 2 and this one, just leave it, and that it's either way. Well, I suppose you can't do it either way, but they both equate to the same thing, being PbNO3 is the limiting reactant right here. So for D, we're supposed to calculate the molar concentration of NO3 negative, aqueous in the mixture after the reaction is complete. I said PbNO3 2. I rewrote the equation here, sorry. And I took the moles of our limiting reactant, because that's also where NO3 is, PbNO3 2, times 2/1, because for every 1 PbNO3 2, there are 2 NO3s due to this little guy right here. So I multiply this by 2 to get 0.000906 mole, or 9.06 times 10 to the negative 4th. And then this we take to find the concentration, the molar concentration. We divide the moles by the liters to get the molarity. And then E, we were asked to pick, of the 5 pictures here, which one, circle the diagram below that best represents the results after the mixture reacts as completely as possible. Explain the reasoning in making your choice. For this reaction, we know that PbNO3 2 is going to be used up first to form PbI and 2 NaNO3. But all of this is going to be used up in forming these things. So I chose this one because it has I and Na left over, excess I from the first side here, and excess Na as well. Not obviously. Oh wait, no, you know what? That's not right, because the I isn't a spectator, because it ends up going in here. So sorry, that's incorrect. It's actually this one where there's NO3 and Na left over, because the Na3 is a spectator ion, and the Na is excess from the left. I don't know, you should be able to see it. Yeah, this one's the right one, not the other one. Sorry. Oh. Okay, so go through it one more time. Da-da-da.